This is Rajendra Wagh. Welcomes you in today's lecture. Today's topic is electric field perpendicular to the direction of motion, and this is the subtopic of a charged particle placed in constant electric field. Okay, in previous lecture we discussed the first case when electric field is parallel to the direction of motion, and in this lecture we are going to discuss the electric field perpendicular to the direction of motion. Okay, so let's start now. Friends, let a constant and uniform field is applied along y-axis. This is along y-axis. Now a particle of mass m entering into the field along x-axis with initial velocity ux. This is initial velocity. Now Vx is taken as a general velocity now, and Ux is here the initial velocity. Okay friends, now the force acting on a charged particle along y-axis with initial velocity Ux is Fy is equal to Q into Ey, right? Fy is a what? Force component acting along y-axis on this particle. Okay, so according to Newton's second law, we know Fy, that is force, is equal to mass into acceleration. Mass into acceleration. Okay, so acceleration can be written like this: dvy by dt, that is rate of change of velocity along y direction with respect to timing. This is now replacing this Fy. Okay, m dvy by dt is equal to Q into Ey. Ey is what? Ey is nothing but applied electric field along y direction. Okay, now same equation can be written as dvy by dt equals to Q Ey divided by m, or you can write dvy is equal to Q Ey divided by m into dt. Now know this equation as a 3, right? Now integrating above equation, we get integration of dvy is vy is equal to, this bracket is constant, so remain as it is, Q Ey divided by m into t. dt's integration is t, introduced c1 is a constant of integration. Okay, now this c1 at t equals to 0, particle enters along x-axis and therefore velocity along y-axis is 0, right? Therefore c1 is also 0. Okay friends, so we get the constant of integration, value of constant of integration. Thus we get vy equals to Q Ey divided by m into t. Here plus c1 was 0, right? Okay, now we know that vy, that is velocity along y-axis, is equal to rate of change of displacement along y-axis with respect to timing, that is dy by dt, and therefore by putting this value here we get equation dy upon dt is equal to Q Ey divided by m into t. Okay friends, now rewriting this dy is equal to Q Ey divided by m into t dt. Now integrating this equation, we get y equals to half Q Ey divided by m into t square plus c2. Now c2 is another constant of integration whose value is calculated by taking initial conditions. Let the particle be entering at y equals to 0, then c2 equals to 0. Okay, now therefore the y equals to this equation, by putting c2 is equal to 0, we get y equals to half Q Ey divided by m into t square. Okay friends, call this equation as a fourth equation. Since there is no force acting along x-axis, no force acting along x-axis. The velocity along x-axis is constant and equal to initial velocity ux. Okay. Now, the distance traveled by the particle in time t along x-axis is x equal to vx into timing. Friends, this is a simple formula. Distance is equal to speed into timing. Okay, so rewriting this in the form of t equals to x divided by vx. Call this as equation 5. Now substitute the equation 5 in equation 4. We get, that is, by putting the value of t in equation 4, we get y equals to half q ey divided by m into x square divided by ux square. Okay friends, right? So x square can be written as x square is equal to twice m ux square divided by q ey into y. Okay, so call this equation 6. Right? Now compare this equation like this: x square equal to 4ay. Now what is exactly 4a? This bracket. 4a means what? This bracket. So 4a is equal to twice m ux square divided by q into ey. Okay, thus we can say that by comparing this equation, this is the equation of parabola, right? So the path of the particle is parabolic in xy plane, right? So from this equation, from this derivation, we can say that when electric field perpendicular to the direction of motion is applied, right, that particle performs parabolic path. Okay friends, so friends, for this lecture this is all about. I hope you understand. If you have any doubts, you can write in comment box. Thank you.